Alright, so here's Earth. You're pretty familiar with it. We're going to zoom in. We're going to keep zooming in to a little kind of area that I thought would be easy to kind of mess around with, down past all these farms. And when we're down here, I'm going to put a little clock. Kabang. The clock. Yay. It works. It's not the best clock. Yeah. You get it. It's a clock. So we're going to zoom back out through my not so subtle transition of Google Earth imagery versus kind of a picture that I'm using of Earth, so I can kind of explain this better without messing around with all this Google Earth stuff. Very subtle. So we're going to move that out of the way just to make things easier. And now we're going to put a clock there for what I'm going to explain later in the video. Alright, so this clock is what we would call Earth time. It's moving as what you would see this clock moving on Earth. This clock is, we're going to say, in still the same location as you saw earlier, right back near those farms. It moves just at the same speed as any other clock would on Earth. You're standing right next to it. It looks like a clock. It's moving one little tick per second. It was kind of annoying to kind of calibrate it, but it should be exactly 1 second per little tick if I don't have any lag when rendering this. Yeah, it's a clock. I mean, it's pretty easy. It's big because you can see it better, but that's on Earth. It's not moving relative to Earth, and yeah, that's going to be kind of our base point for the rest of this video. Alright, so this clock is obviously shooting off little photons in all directions, but for the sake of this video, we're going to shoot all the photons in one direction, just so we can simplify this easier. So you can see the photons kind of shooting off each kind of frame, if you will. Alright, so let's play that back and let's slow it down so we're only shooting one frame per every 2 seconds. Now I think it's important for you guys to realize that in reality it doesn't actually shoot a frame. It's just a constant flow of light that's bouncing off the clock face and it's going out into the universe. But for simplicity's sake, I'm going to slow it down so it's only one little quote-unquote frame for every 2 seconds. And I think that will make things a little bit easier for you guys to understand. Alright, so if we put an eye in here, and the eye is looking at the different frames that are coming to it, the frames are going to be different than the ones that are actually on Earth. That's because the frame, or the light particles shooting towards your eye, do not change on their flight through the universe. They can only change on Earth, where the actual thing is. Now the important thing is you're not actually seeing into the past, you're actually seeing the present of what is going on in front of you, what the clock looks like on Earth to you. Now obviously it's not at the exact same time as what's going on Earth, but it's a different time for you, which is kind of important. So now I'm going to show you what happens if you're in a rocket ship and you're running away from Earth. Alright, so the first thing that I want to say is no rocket ship will ever go as fast as these little light particles that I'm shooting out, because these light particles are traveling at the speed of light and no physical object can travel that fast. So obviously it'll always be a little bit slower, but it'll still be interesting, trust me. If the ship went at the speed of light, it would be flying with the frame of light. It would see no change in the time when it looked back on Earth. To the people on the ship, everything would stay the same. It would be stationary. The light would also be absorbed, so it would look black when the ship looked back. This would never be possible, as the ship could never move the speed of light. This is just a thought experiment. If the ship traveled slower than the speed of light, it would look back and see new bits of light coming from Earth. The light would be dim, but still viewable, as there would be less light hitting the ship than if the ship was standing still. Instead, the ship flies alongside the light, but the light will always be faster. If they had a clock on board, their clock would be moving quicker than the clock they saw on Earth. This is one way to think about time traveling. And yeah, that's about it. So if you guys could leave any feedback that you guys have, it's my incredibly simplified video. Not too sciencey. Usually people will be able to understand this. Every time I explain this to my family or friends, they're usually able to grasp the concept pretty quickly, and it kind of really blows their mind how simple it all is. Hopefully this video kind of explained this to you guys a bit better. The real reason I'm making these videos is for me to get better at video editing and kind of public speaking and all that. So hopefully this will kind of improve. So yeah, hopefully you guys enjoyed. It is kind of a unique concept the way I'm doing it, instead of kind of using other videos on YouTube. This way it's kind of even more simple than kind of the simple videos out there. I made this just to kind of so more people can kind of understand the concepts that I'm trying to talk about. And yeah, hopefully you guys enjoyed. So thanks for watching.